All right, we're in section 8.2 where we're going to use properties of parallelograms. So in these lessons here, it says if a quadrilateral four-sided polygon is in fact a parallelogram, then these things are going to be true. First off, the opposite sides are congruent. So if you look here, this side and this side are the same measurement. So is this side and that side are the same measurement. And the opposite angles are congruent. So if you look here, these two angles are congruent, whatever they happen to be, and these two angles are congruent there, whatever they happen to be. From that, creates some um, other things that are true. One, which is consecutive angles are going to be supplementary. So kind of erase these things here. That means that whatever value of this angle is plus whatever value of this angle is going to equal 180 degrees. Okay? Same thing goes for something like this. The result of that sum will be also 180 degrees. Okay? So, from those uh, from those characteristics of a parallelogram, we can use that to our advantage to help us find various unknowns within the parallelogram. So in this case here, it says the example, they want us to find the value of each variable in the parallelogram. Because it's a parallelogram, then they told us that. That means that even though it doesn't have any markings and stuff like that, it has the characteristics of a parallelogram. Also, the two opposite side lengths are parallel. So what we can say from the information that was given to us above, because this value here is 8, this value here is also going to be 8. So just from looking at it, x is going to equal 8. And these two here are opposite angle measures. We were told that opposite angle measures are congruent. Y is going to be 60 degrees. Over here, same idea, but we're going to have to do just a little bit more algebra because these two side lengths are congruent. We can then say that y plus 3 will then be equal to 18 to find the value of y. Subtract 3 from both sides, y equals 15. Again, these two are opposite angles. We were told that those opposite angles are congruent. We can say that then 50 will equal 2x. Divide everything by 2. X will equal 25. Look below here. Same thing. These two side lengths will be congruent. We can say that x plus 4 equals 12. Subtracting 4 to both sides. X is 8. These two are congruent. There's no algebra that has to be made to solve it. X is also going to be 65. Okay. Another characteristic of a parallelogram is that when it says if the quadrilateral is parallelogram, then its diagonals bisect each other. Okay, so you have one vertex, and then inside of the parallelogram, it's connected to the opposite vertex, and same thing goes here and here. All right, those two line segments will meet at this point. All right, why is that point significant? From what it says, if they bisect each other, that means when they bisect, that means they split this line segment here and this line segment here into two equal parts. Same thing goes for here to here as well. So with that information, we can use that to help us find uh, the value of each of the variables um, in the parallelogram. So not only do we have this new information that things bisect, but we also know about the previous characteristics from the first page. So we can say that from here to here is 10, and here to here is 2x. Well, we know it's a parallelogram, so we know that those two line segments bisect. And so I can say that 2x is going to equal 10, which then dividing everything by 2, x would equal 5 in this case. From here to here is 8. From here to here is y minus 6. To find y, you're just going to take y minus 6 and set it equal to 8 because those two bisect each other. Add 6 to both sides. We now know that y is going to be 14. Now this one here has some angle measures, okay? So now what we have to do is resort back to different things that we learned not only from the previous page, but some different characteristics of triangles and also different characteristics of even transversals. So we have essentially when these parallelograms have two bisected line segments, they create four triangles. All right, I got 1, 2, 3, and 4. Okay, we have four triangles, and all of them have all the characteristics that we have previously learned from different chapters. We can say that the sum of all the interior angles of a triangle will equal 180 degrees. We can talk about, since it's a parallelogram, that means that this line segment is parallel to this line segment, which means this line segment is parallel to this line segment as well. Let's make it 1, excuse me. And that will help us determine uh, different things. We also can talk about linear pairs. Excuse me, linear pairs is when you have two angle measures right next to each other. We know that the result's going to be 180 degrees. We can talk about vertical angles, so on and so forth. So to get this started, what I see right off the bat is I know that this angle measure right here is going to be 55 degrees. The reason why I know that is because these two are vertical angles. And so since they're vertical angles, I know that they're going to be congruent. So what I have created is two angle measures for this triangle right here. And then I can find y by taking the sum of 96 plus 55 and then taking 180 and subtracting that. So I can say, essentially, if I wanted to write this out as an algebraic equation, I could say that y plus 96 plus 55 will equal 180 because the sum of all the interior um, angles of a triangle equal 180 degrees. So 96 plus 55 equals 151. If I took, let's write that down. And so if I took 180 and I subtracted 151, I would get y equals 29. So I get y is 29, 29 degrees. Okay. Now, another thing that you can do is I can look at, this angle measure here, the relationship between this angle measure and 55, is there a linear pair? And so I could say that 180 minus 55 is going to give me 125. So since they're 125, I can use that to my advantage. Other things you can kind of say is, all right, this is 125 also because of vertical angles. And we can also say that since I have 96 right here, I could also say that this is also going to be 96 because of alternating interior angles if this was like a transversal. So if this is 96 degrees, I can say that then x is 39 degrees because of alternating interior angles. And finally, I can then find z by taking z plus 39 plus 125, and that would be set equal to 180 degrees because it's a triangle. 125 plus 39 gives me 164, and z plus 164 equals 180. So I got 180 subtracted by 164, and I get 16 degrees. Okay? And that's it. And that is being able to use the properties of parallelograms. Oops. Till next time.